colleagues, hello everyone. So today in this lecture I would like to perform you the information about non-power applications of nuclear and radiation technologies with subtopic about research reactors. So I am Maxim Kublinskiy, so I work at Tomsk Research Reactor as a nuclear engineer, and in some short words I would like to start with the introduction about nuclear research facilities. What is it itself, actually? So this is kind of a facility that includes a nuclear reactor or subcritical assemble or critical assemble, which is used for obtaining some neutron flux and ionizing radiation for the purposes that were prescribed by the project of the we can divide them, as I told you, on three different classifications. So actually the first one is subcritical stand. So the example for you is performed in the slide. So this is model 9000 in Greece. So subcritical stand is used for different purposes for obtaining the neutron flux as well. If we talk about critical stand, it is nearly same, but for different condition of neutron flux. And the third example is our Tomsk Research Reactor itself. So we use it for different purposes that are going to be described in this lecture later. Again, so how to classify the facilities? Yes, so the first is appointment. So for what we generally use it for. So it's physical research, so some activation analysis, so defining physical properties of the material itself. Also, as I told you, material science research and isotope production. So, for example, radiopharmaceuticals is related to this part. If we talk about the flux density, we also can divide them in three. So this is low flow, medium flow, and high flow facilities, so with different values of neutron flux. Again, so operating mode is dependent also. So here we have the pulsating and long work station reactor. So by the way, Tomsk Research Reactor is long work, so actually it has some stationary condition, so it works for some time that is going to be described later in the lecture. And the neutron flux spectrum, so as it's known, we have fast and thermal neutrons flux, and these different neutrons can be used for different purposes. Applications of a research reactor are widely shown on these slides. So the number of reactors is pretty high, and the major part is related to teaching and training. So together with Tomsk Research Reactor as well. So 172 reactors among the world correspond to teaching the personnel and teaching and training the personnel for some other purposes, for building the nuclear power plants or for some operation on existing power plants. So, if we say about TPU facilities of equipment, so again, our main stuff is nuclear research reactor. So this is our main nuclear research facility. So our thermal power is of about 6 megawatts. So we do not have electrical power. So we do not produce electricity. Laboratories in our building related to different topics, for different purposes. We have the silicon doping facility, we have the radiopharmaceutical doping facility, and also we have the huge facility for activation analysis, which is which can be done by neutron flux and ionizing radiation that we get from the reactor core of Tomsk Research Reactor. So also we have a cyclotron, but about it later in that lecture. So again, in short words about Tomsk Research Reactor, so it is a pool type reactor. It is really important part, so we can clearly see the reactor core, so you can see that on the photo. And we have a huge large amount of abilities for experiments. So these are 10 horizontal and 14 vertical experimental channels. So again, for different purposes of ionization of the samples, so for some subsequent purposes of analysis. If we say some words about the construction of the reactor core, so we have the uranium dioxide fuel with 90% degree of enrichment and beryllium reflector blocks, which are used as a neutron trap, so which is really important for the reactor operation and the reactor startup. So reactor is a light water moderated reactor, and some values for physical parameters actually with assigned lifetime. So we have a enlarged lifetime until the 2035th year. Again, so what are the application fields of a nuclear research reactor? So the first thing is about the obtaining new diagnostic and therapeutic radiopharmaceuticals. So it's related to transformation of molybdenum and technetium-99s. Also, neutron capture therapy for cancer treatment methods, so actually with the implementation of boron and neutrons into the volume of the human body, for example, or some living organism body. Nuclear transmutation doping of silicon for the production of high current semiconductor technology laboratory, and radiation material science, actually neutron activation analysis, which is also really important for some physical investigation purposes. Another nuclear and radiation facility is R7M research cyclotron. We also use it for different purposes. It's located in different building, but again, so we have the channel for neutron therapy in oncology. So as it is so cyclotron. So this is a device for acceleration of ions. So the main aim of this assembly is to accelerate ions ranging from argon-14. If you say about application fields, so it's slightly different. So fundamental studies of the ions interaction with matter and activation analysis as well. So the same stuff related to the reactor. So we have a neutron therapy and production of radiopharmaceuticals ability as this. And so some samples of betatrons actually. So the type of radiation is Bremsstrahlung, beta radiation with the shown range of the energy and shown value of power consumption on the slide. Application fields are also scientific but different. So radiography, film and digital, so tomography of aerospace and superficial radiation therapy. So this is all about nuclear and radiation facilities for Tomsk Polytechnic University. So I'd like to thank you for attention and see you next time.